Perfect. So who am I? As Fredrik said, I work as a research scientist at Sleep Cycle. Has anyone here heard about Sleep Cycle before? A few. And then I guess, have anyone used our app? 2. Perfect. But before joining Sleep Cycle, I was a PhD student founded by Cher at the DSAI division here at the CC department. And yeah, I graduated basically like end of November last year. And my supervisor was Devlet Dubachi. I've seen him in a few of the slides here today, and Fredrik was my co-supervisor. And back then, I was focusing on reinforcement learning. So we did a lot of cool reinforcement learning stuff, basically on two themes. One was reinforcement learning and language. So we had the reinforcement learning agents interacting with each other, solving common tasks, and developing their own language, so their own communication protocols. And then we also looked at something called multi-armed bandits. I don't know if you have encountered that, anyone? It's in some of the advanced machine learning courses. So the basic setup is that you're at a casino, you have a bunch of these one-armed bandits, and you want to maximize your rewards. You want to figure out which machine is the best one to play, and then you want to keep on playing that forever. A weird model, but it turns out that that has a lot of applications in the real world. For example, finding the optimal drug dose, finding the best ad to show to someone, finding the best movie to recommend to someone on Netflix. But the focus of my talk today is not going to be on this, but to give you some ideas of what you can do in industry here in Gothenburg when it comes to AI and machine learning. So I'm going to give you a short introduction to Sleep Cycle, because most of you haven't heard about us, and how we kind of use audio event detection and machine learning in our products. And then I'm going to talk about 2 projects that I'm involved in currently. One on how we take sleep data and turn this into like a worldwide sensory network that we can use for public health monitoring, and some ongoing research projects on that matter. And then you can't have an industry talk without generative AI, so I'm going to talk a little bit about how we use generative AI in our products. So what is Sleep Cycle? So I was joking before this with one of my former colleagues here that some of these slides I've made myself, some I've taken from other people at the office presentations. You can guess which one. This is your only training example. So there was someone here that had a training algorithm that only worked for one example. So this is not my slide. So let's see if you can figure out which slides are mine and not. But in short, we are the world's most popular sleep app. So we have over 75 million installs. We have tracked more than 3.4 billion nights. And we have 3.2 million monthly users, so unique users of our app. And we are available on all markets and on all leading platforms. So just to give you a quick idea of what we do, in our app we offer a few different things. Soft things like relaxation and sleep aids that you can listen to. But the kind of core thing that I work on and the main thing with this talk is the quantitative side. So what we do there is we use audio event detection to see how much are you snoring, coughing, stuff like that during the night. That's just one feature our user likes a lot. So if you're fighting with your partner on who is snoring, you can use our app, and then we can tell you in the morning. I don't know if you're saving marriages or not with that feature. The other one is our smart alarm. So you set a wake-up window. Here it's between 7 to 7:30, and then we will wake you up when you're in light sleep. So you're going to feel more refreshed. And then the end is this working properly? Perfect. Is just computing a lot of sleep metrics. So sleep stages, onset latency, anything related to sleep. And we do this with audio. So why audio for sleep? Well, we capture a lot of interesting things. We could capture your breathing rate, snoring, coughing, movements, and related things. And the nice thing with this is it's a non-invasive alternative to wearables. So you don't have to have a watch or a ring. You need a smartphone, and most people nowadays have a smartphone, and that's what you need. So the way it works is that you put your phone next to your nightstand, and the phone keeps listening and keeping track of your sleep while you're sleeping. And if you have the smart alarm, it's going to wake you up when you feel the most refreshed. And I think it's one thing we should note here is that this is done on device. So the data stays on the device. We do the computation on device. So it's fully private. And since we have so many users, we wouldn't actually be able to afford computing this in the cloud because we're processing petabytes of data every night. But in practice, what we do on the phone is that we have a deep neural network that we have trained on large in-house datasets. That we have, some of them are open datasets that we've used, some of them we have collected ourselves, because many of our users actually consent to us sampling short audio clips from them that we could annotate in-house. And actually, many users like to annotate their clips themselves, so they actually annotate the clips and send them to us. There is some bias in training on that type of data that we can talk about during the mingle. But this kind of deep neural network becomes our foundational model, you can say. So with that, we can do a lot of downstream tasks. For example, we can map which sleep state you're in, because there's a very nice correlation between your breathing rate and your movement and what type of sleep state you're in. And we can do things like onset latency and more stuff that I will come to quick in a few slides. So just to give you a sense for how it looks, this is my night a few days ago. I took the best night I had this month. I have a small toddler, so I never usually get more than 5 hours sleep. Here I got 5 hours and 50 minutes, so this was good. But this is how it looks. So this is what we can measure with this deep neural network. But if we take a step back, so something that we kind of realized a while ago is that we're not just kind of providing the user with interesting data about their sleep, but since we have so many users, we're actually some sort of global sensor network for health. So we started thinking, okay, could we do something cool with this? As I said before, we're processing petabytes of data, as it's 70 terabytes of data every 10 minutes. And we detect so many health markers, like breathing, snoring, coughing. So we started with coughing and thought, okay, could we somehow build like a live stream of the world's coughing? So let's see. So that was basically when Cough Radar was born. So what we were using here is a technique called differential privacy. So I think this is kind of... Yeah, I think now it works. No, so we use differential privacy. So before your coughings leave the phone, go to our server, we clean it from any personal information. We add some noise to your position, so we don't really know where you are. Maybe in the neighborhood, but there's a noise added. And from that, we kind of aggregate all the user's data, and then we plot it as a map. So this is this Cough Radar feature. You can zoom in on any city in the world. Basically, in many cities, we have tens of thousands of users every night. And you can see on a neighborhood level how coughing is evolving over time. So if you... we have a web page where you can go and see how it's going for in your neighborhood. And you can set up notifications if there's rising coughing in your area. And just to give you like a sense of how big this data set is, there is actually no world map in this figure. So we've just plotted every data point in this data set for one day. And we basically cover most of the world except Sahara. There aren't that many people living there. So this basically, like, it started as a cool feature in the app, but we kind of quickly realized that, okay, there could be something more to this. Could we use this for epidemiologic forecasting? So we started looking into public health surveillance. And there you have many problems, but these were the 3 ones we started looking at. Usually there's a latency problem. Like traditional reporting-based methods are very accurate, but they lag. So if you're a hospital, well, it might take 2 or 3 weeks before the reporting gets to the local authorities. So it's basically this lagging makes it very hard to act on this data because you will usually just learn what happened 3 or 4 weeks ago. And then another problem is accuracy. There are faster methods like web search that have super low latency, but are usually very noisy. People could Google for many reasons. And these effects, when you look at search-based, usually decay off very fast. And then you also have a consistency problem. Different countries measure in different ways. Different cities might measure spreading patterns in different ways. So this is also hard. So what we kind of felt that we were doing was that, well, we are super fast. In the morning, we know how much people coughed in this area. We are accurate. We are measuring symptoms, not people Googling. We're actually measuring health symptoms. And we are consistent. We're using the same deep learning model in every country around the world. So the first thing we did was, okay, let's just check how good we are. So we looked at the US, and then we looked at people hospitalized due to respiratory illness, such as COVID or influenza. So on the top here is New York. So you see patients hospitalized on the y-axis, and on the x-axis you have dates. And below there you have the average coughing. So yeah, you see that there is very strong correlation. And what we found is that usually we can tell 2 weeks before there is a peak in hospitalization that there will be one. So this we got like some sort of award at this ECMID conference. When we published this abstract, there is a lot more to do here when it comes to confounding factors, implementing this as a forecasting system. But we are teaming up now with several research groups in the US to see if we can actually take this cough radar data, this live stream, and see if we can do something with a real forecasting system. Let's see. Yes, and this is something else we just put on archive. So this is a preprint we've done together with some of our collaborators at the University of Cambridge, where we looked at, okay, could we measure effect of air pollution with our cough data? So the long-term effects are well studied. If you're exposed to a lot of air pollution, it's going to be bad for you. But the immediate effects are actually quite underexplored. So what happens if you're in the morning exposed to air pollution? What happens during the night? So that was what we wanted to try. So we compared air pollution data with our cough rates. So in the previous slide, we were kind of treating cough data as X and wanted to predict Y. But here we're actually treating it as Y. And the X value is the air pollution. And so we took 30 cities in 12 different countries, and some of them had very clean air, some of them were very dirty air. And then what we found was that, so this is the air pollution on the x-axis, and the percentage of increased coughing on the y-axis. So we find a clear effect. And what was quite interesting in this study was that we saw that, so the red line you see there is actually the World Health Organization's threshold for what constitutes like dangerous air pollution. And we can actually see that there is an effect. Small, but there is an effect below that average as well, below that thresholds as well. So there seems to be no safe threshold when it comes to air pollution. Right, so just to summarize this part, what I think is cool with this data, we're also looking at breathing rates, doing the same thing, like a breathing rate radar, is that we're measuring health or health outcomes in large scale with minimum lag. And there's been a lot of interest from academic partners. We're actually getting contacted almost every week now. So we have an ongoing collaboration with Cambridge, and we have several upcoming collaborations with Ivy League universities and top universities in Singapore. Let's see. But let's jump to the generative AI stuff that we're doing. So last week we released our Luma AI sleep coach. It's a little bit like the Clippy from Words. We're kind of bringing that back 30 years later. But the challenge we have in our app is that not all our users are data scientists. Some of them are. Some of them love to export the data. They have used this app for thousands of nights. They export it into a notebook and plot and do their own stuff, but most of them are not. So how can we turn these raw values that might be very hard to interpret into more like digestible insights? And then another challenge that we have is that we do have sleep experts hired at the company. So we have a lot of material and knowledge on how to behave and what we should recommend in certain situations. How can we better map that to these insights? How can we better coach users and help them feel better? So what we've done is we've taken this interface and then turning it into a chat. So you go into this. This is how it looks currently, and we're kind of constantly iterating on it. That you get, when you enter the chat, you get some suggestions, and this is a kind of interesting reinforcement learning problem on which things should you suggest for the user to talk about. You click on it, and then the model looks at your data, computes what seems to be the most interesting plots, and then also suggests follow-up questions. And the way this works, more like the structure behind this is that the user writes a prompt, the LLM gets the prompt, and then uses something that is called an MCP server. How many have heard about MCP servers? A few. So you can think of that as an API for large language models. So it's a protocol that all or most LLMs are used to, so they can basically interact with this API and fetch data. So in our MCP server, it can fetch user data. There's tools for analysis. So instead of feeding raw value into the LLM, that would most likely cause hallucinations, we have tools that the LLM can use to run analysis, such as searching for trends, computing averages, correlations, doing statistical tests. And then the LLM can also fetch relevant sleep resources. So you can think of when ChatGPT does web search, our LLM can make search in a curated database. And then in the end, it outputs something that is called a structured output that basically defines. So the LLM is not generating these plots. It is outputting a function call that's going to be executed on the phone to plot this. So again, if it were to generate these, it would most likely hallucinate. So I think this is really fun to play around with. And as a company now with LLMs, if you sit on a lot of data, it is very easy actually to set up some sort of LLM layer so you can chat with that data. And for my second to last slide, I think, this is more for the mingle. There's a lot of, if you're interested in reinforcement learning and bandits, there's a lot of interesting problems when you're designing chats like this. So how should you select these conversation starters? How do you decide what is a good follow-up question to a user prompt? That's something preference learning you can look at there. And we're looking into using RLHF, so reinforcement learning with human feedback, to actually fine-tune what type of questions are we asking the user, or suggesting the user to ask the LLM. So just to conclude, I think at Sleep Cycle we are a very small team, but we are definitely punch above our weight when it comes to data science and AI. And what I think has been really fun is I was a little bit afraid when I stopped being a PhD student that I wouldn't be able to do research anymore, but we're actually able to work with large-scale data and top universities such as Cambridge and Harvard and more to do really cool research. And you get to use AI to help people feel better. And I didn't have time to mention this, but we're also doing some sort of sleep apnea screening. So that's a big problem nowadays. And we're running a clinical study for designing a screening tool for sleep apnea. And in general, it's very interesting times to be in AI and industry. So this is our team. If you felt that this sounded really interesting, we are hiring. We aren't actively looking for master students or master projects, but if you come up with a cool idea, I'm very eager to listen to it. Thank you.